Hello and welcome to this year's Awesome Day online conference for 2023. My name is Aarti Natarajan and I have the pleasure of being your AWS technical trainer for this session, Introduction to the Cloud. As a technical trainer for AWS, I spend most of my time working with those interested in learning about AWS services. From a technical, how does this work perspective, to a hands-on, how do I use this in my operational environment, to how can I architect a solution to meet my business needs. I teach a variety of courses such as architecting on AWS, developing on AWS, and machine learning. The cloud is an ever-changing space, so it's always great to hear about new use cases and customer stories. I particularly enjoy facilitating discussions with customers that gets us thinking about building innovative architectural solutions on the cloud, turning ideas into opportunities and helping us to serve customers better. It's a pleasure today to walk you through the different foundational services as well as some new ones in this year's Awesome Day. Today, we'll be walking through some fundamental concepts and key service areas to kickstart your learning journey and help you prepare to start building on AWS. In addition to that, we'll be discussing a few innovation areas you might be interested in knowing more about. This session serves as a great introduction to the AWS cloud. So no matter if you are completely new to AWS or just looking to learn more, you are in the right place. First up on our agenda, we're going to do an introduction to AWS and dive into some of the key foundational areas: compute, storage, databases, networking, and security. In the second half of our session, we'll shift our focus to some other really cool services that enable innovation on AWS. Looking at how AWS services can help you manage the Internet of Things, machine learning, maybe stand up a blockchain, or even control and process satellite communications with AWS Ground Station. We're also going to be talking about AWS Wavelength, a relatively new service that's underpinned by 5G technology, and how we can use that to build applications that deliver ultra-low latencies to mobile devices and end users. At the end of our session today, we will talk about next steps. What you can do to get hands-on, start building, continue learning, and also maybe even get AWS certified. So let's get started with the introduction to the cloud. Firstly, what is the cloud? I like to think of it as simply someone else's computer. But what does that mean? Well, you're connected into this Awesome Day session on your computer, maybe a personal laptop, maybe a work laptop, but either way, you are the primary user of that computer. You use it, you keep it secure, you restart it when you have to install updates. Essentially, you are in control of it. But on the flip side, if you break it, you're also responsible for that. Likewise, if you think about what you have in your on-premise data center, you typically have servers, storage, networking, and databases. And you have applications and workloads running on these physical resources. The cloud doesn't operate all that differently. You're still going to have those resources and have the ability to access them, but you're just going to do it in a much more flexible manner over the internet. With the cloud, another service provider, such as AWS, takes care of those physical resources such as servers, storage, networking for you. You don't need to manage the physical side. You just get to run your favorite applications without having to deal with that underlying infrastructure. So with the cloud computing, it changes the way we look at the infrastructure and envision, if you will, it's all software that we configure to do what we needed to do with agility. You access the physical resources you need essentially as a set of programmable resources. You can easily provision a server or increase database throughput or maybe compute power, as we'll see later, with really just a few clicks. The use of IT assets as programmatic resources gives you elasticity to be able to quickly set up and tear down infrastructure in a way that isn't possible with the traditional approach. Another key benefit of cloud computing is the ability to pay as you go, letting you test and leverage the system without being fully committed. You can stop using these services at any time and you only pay for what you consume. Finally, the best part is we can deploy the infrastructure globally in minutes. Let's now talk a bit more about the advantages of using the cloud as compared to, for example, your own on-premise environment. Firstly, we have what's called trading capital expense over variable expense. Instead of investing heavily in data centers and servers before you know how you're going to use them, having a variable expense simply means that you are going to be paying for those infrastructure resources only when you consume them. And by taking a cloud computing approach that offers the benefit of variable expense, companies can implement innovative solutions while saving on costs. What this really means is that you can now deploy a workload and start getting immediate return on investment without having already committed a large financial outlay and the associated risks that it entails. The second advantage that we have is benefiting from the massive economies of scale. By using AWS Cloud, you can achieve a lower variable cost than you could get on your own. Because the usage from hundreds of thousands of customers is aggregated in the cloud, AWS can achieve higher economies of scale, and those economies of scale translate into a lower pay-as-you-go price because AWS passes these cost savings to you. Next, you can stop guessing capacity. It is in an on-premise environment when you make a capacity decision before deploying an application. You're often going to end up either sitting on an expensive idle resource that's not being used adequately, or maybe dealing with limited capacity if you decide to set aside less resources upfront. With the cloud, you no longer have to think about what your infrastructure capacity needs to be in 3, 6, 12 months, or even years from now. By utilizing AWS Cloud, you can provision only the resources you need for any given capacity. You can add or remove resources as your requirements change, which leads us nicely to increasing speed and agility. In a cloud computing environment, new IT resources are really just a click away. It no longer takes weeks for developers to access resources they need. The resources can be made available in minutes. This allows you to respond to unexpected capacity changes. For example, your marketing campaign was more successful than you expected, or planning accordingly to expected changes. For example, your overnight load versus peak load during the day. This also enables another key benefit. Organizations and teams can spin up a proof of concept, and if it's not working out exactly as intended, they can fail fast, so as to speak, and stop using these resources right away. As a result, organizations can iterate their development process quicker, at a lower cost, and ultimately go to market sooner. We have this term in AWS, undifferentiated heavy lifting, which refers to the actions and tasks that you currently perform that don't add direct value to your business. For example, imagine your business owns a data center. Then you would have to purchase the equipment, employ administrators to manage that equipment, and ensure it runs optimally over its lifespan. Now think about this. Your competitors are likely to have similar administrative overhead. They're going to be having data centers with equipment that needs to be maintained. So how do you set yourself apart? Well, let AWS manage the physical infrastructure. Stop spending money on running and maintaining data centers. Focus on what actually matters to your business, your customers, your staff, and your product. The last benefit that we have here is the ability to go global in minutes. You can easily deploy your application in multiple regions around the world. As we will see with our infrastructure, we can achieve global scale with just a few clicks. This means that you can provide a lower latency and a better experience for your end customers or end users at a minimal cost. So if you're going to be talking about where the cloud actually is, we need to learn about the AWS global infrastructure. AWS global infrastructure is primarily made up of regions that you can think of as geographical locations. You need to deploy a workload in Australia? No worries. Deploy that into the Sydney region. How about running a workload in Europe? Great. You have plenty of regions to choose from. London is just one example. There are multiple regions deployed globally. An updated list can be found on the AWS infrastructure page, infrastructure.aws. Next, we have availability zones. Availability zones, or popularly known as AZs, are a subsection of a region. An AZ is a fault-isolated domain which allows you to create high availability within your applications. Availability zones have their own power supply, network connections, and are designed to be on different floodplains and accessed via different infrastructure. This means that a single AZ failure should not impact other AZs. This gives fault tolerance to the region as a whole. A region is typically designed with 2 or more AZs to ensure high availability and fault tolerance. Each availability zone is made up of 1 or more data centers. The data center is a highly secure facility housing all of the physical infrastructure that makes up the cloud, such as compute, physical disk for storage, networking equipment, amongst other devices. For the majority of workloads, you will typically interact only with the region or availability zone. AWS infrastructure regions meet the highest levels of security, compliance, and data protection, and there are currently 31 regions worldwide. Another important infrastructure element is the edge infrastructure. Displayed on the screen are the edge locations distributed globally. We use these to bring the content closer to your customers to improve performance. They can also be used to increase security and reduce the cost. This can be achieved by redirecting the traffic to the edge locations and caching content. A key service that uses edge location is Amazon CloudFront. We use Amazon CloudFront to build a content delivery network, or CDN. Let's now take a look at the video to understand how the AWS global infrastructure works.
In an ever-changing and uncertain world, AWS has stayed consistent by building resilient, global infrastructure designed to meet your evolving needs. AWS's infrastructure and network is architected to meet the highest levels of security, compliance, and data protection. From day one, AWS knew the importance of supporting high-transaction, low-latency applications that can replicate data between geographically dispersed data centers. That's why each AWS region is built with multiple availability zones that are separated from one another by a meaningful distance, and each have their own redundant power, networking, and connectivity. AWS's expanding global infrastructure portfolio is here to meet your needs. Choose the infrastructure type you need to build highly available applications and get performance that exceeds expectations. Pick any region around the globe for your most demanding workloads. You can use CloudFront to quickly deliver your content, AWS local zones for low latency applications, AWS Wavelength to deliver powerful 5G applications on demand, and bring the cloud to your data center with AWS Outposts.
We also have additional services that operate at the edge, including AWS Outposts, local zones, and AWS Wavelength. Let's start with AWS Outposts. Outposts is a fully managed service that extends the AWS infrastructure, AWS services, APIs, and tools to virtually any data center, co-location space, or an on-premise facility, providing a consistent hybrid experience. Local zones is a new type of AWS infrastructure deployment that places AWS compute, storage, databases, and other select services closer to larger cities, industries, or IT centers where there's currently no AWS region. And finally, we're actually going to talk about this one a little bit later, AWS Wavelength, a new service that works with 5G technology. Now, if you think about what resources you have on premises, AWS has services that can map to meet the need. Thinking about security, you might already be familiar with firewalls, access control lists, and maybe even have network or security administrators within your team or your company. AWS has services that enable you to deploy similar security constructs. We have security groups and network access control lists, which we will talk about in the networking module coming up. We've also got a service called Identity and Access Management, or AWS IAM, which helps you to provide authentication and authorization to the users of different AWS services that we're going to talk about today. So you have the ability to manage that through one single service. From a networking perspective, you might be familiar with physical devices such as routers or switches, or basic networking concepts such as IP addressing, traffic distribution, and flow. We have services such as Elastic Load Balancer, which gives you the ability to distribute traffic among multiple different targets or compute servers, which we'll talk about coming up. Then we've got the Virtual Private Cloud, or VPC, which is your private network in the cloud allowing you to control how your resources are connected to each other. When it comes to service, you might be familiar with managing, deploying, patching, or operating servers on-premise or maybe in a co-location. A key AWS service to meet this need is Elastic Compute Cloud, which is your private EC2 network in the cloud. We'll talk more about allowing this in the next module, but essentially, how your resources it allows you to deploy a virtual server. When it comes to run your workload, you might be familiar with managing. Now, AWS offers a number of different storage servers on-premise or maybe in a co-location. Whether that's network attached storage and persistent disk, maybe scratch space or caches, or a file system that needs to be shared between different EC2 instances, or even a simple object storage for a wide variety of applications. AWS also has more than 15 purpose-built databases. Amazon Elastic Block Store, or we call that as EBS, it offers easy-to-use, high-performance block storage at any scale. While Amazon Elastic File System, or EFS, provides a scalable, cloud-native, NTFS file system. Amazon Simple Storage Service, or S3, provides object storage that's designed to store and retrieve any amount of data from anywhere on the web, and we'll talk about this in the next module. So hopefully this helps you to apply your current knowledge to different AWS services that we'll talk about. In the coming modules, we are going to go a little bit deeper into some of the different AWS services. Let's have a look at how some of these services can be orchestrated together to build a simple example. Let's say you have a web application that sits on a server that's accessed via the internet. The web application also needs to access some external data sources. As you can see from this architecture diagram, we have different services connected together to build our architecture. In the middle, we have our compute EC2 instance, which being a virtual server, it hosts the actual web application. This application is stored on an EBS volume, which provides block storage to the EC2 instance. The EC2 instance is deployed into a VPC that provides networking access. As far as data sources go, the EC2 instance can access the data in S3, which we said before is an object storage, or DynamoDB, which is a non-relational database. External users can access this web application via Route 53, which provides DNS resolution. We'll speak more about these different services in the upcoming modules. Now keep in mind, this is a very simple example, but you can see how connecting the different services together, you can come up with a huge variety of innovative solutions depending on what your requirements are. I like to think of individual AWS services as Lego blocks, and you put these Lego blocks together to build innovative solutions to meet the customer's business needs. Now, something important to consider is that we have different deployment models and ideas for different cloud maturity levels. What if you're working for a corporate enterprise that was set up prior to the internet? It is likely that you are going to have a large physical infrastructure deployment that you've been using for years. This is what we describe as an on-premise environment. Now, you're not going to want to just turn it off on a Friday night, migrate everything into the cloud on the weekend. On Monday, just start operating in the cloud. Alternatively, what if you work for a startup a brand new company with great revolutionizing ideas, chances are that you're not going to have the financial capital or time or even the desire to invest in an on-premise environment, so you might be thinking of a cloud-native design. So two terms come to mind here. Cloud native, which refers to applications that have been designed and deployed completely in the cloud. Think of newer applications in your business and all in the cloud, where you have migrated all the workloads from your on-premise environment and are now ready to shut it down. AWS cloud deployment models cover all variations across that spectrum. When you think about the legacy on-premise environment that we talked about before, these need to be slowly migrated. So you operate in a hybrid model where you have the workloads and data in both your on-premise environment and your cloud environment. While newer or greenfield applications can be designed with cloud deployment in mind, making use of the higher level services and cloud native design. Ultimately, it doesn't matter where you are in your journey. Once you start moving the data into the cloud, you start making use of the services and advantages that the cloud environment provides you. Speaking of moving your data into the cloud, where does the cloud actually sit? Well, thankfully, the cloud is not some mysterious concept. Rather, it is a concrete service that has physical infrastructure deployed globally, but it's managed for you by a cloud service provider like AWS. So let's summarize what we have learned so far. We defined cloud computing as the on-demand delivery of resources such as compute, storage, databases, analytics, intelligence, and other IT resources over the internet with the pay-as-you-go pricing to provide faster innovation, economies of scale, and flexible resources. We also talked about another key benefit of cloud computing, elasticity. The ability to automatically track and adjust the compute capacity to meet fluctuating workload demands and continue to maintain the performance for applications hosted in the cloud. In AWS, the service responsible for providing this elasticity is autoscaling. Autoscaling ensures that a sufficient number of EC2 instances are available to run the application. We also talked about different deployment models available for customers with different cloud maturity levels. You may have a private cloud within your on-premise environment where the cloud infrastructure is only provisioned for the use of multiple users within the organization or business. Public cloud is what we've been discussing so far, where computing services are offered to you through a cloud service provider such as AWS over the public internet, so anybody can pay and use them. And finally, we also talked about a hybrid model where customers have workloads and data operating in both their on-premise environment and the cloud environment. Let's move on to a few common terms that you might encounter when you're discussing the cloud. Infrastructure as a service, sometimes abbreviated as IaaS, contains the basic building blocks for cloud IT and typically provides access to networking, compute, and storage. Infrastructure as a service provides you with the highest level of flexibility and management control over your IT resources and is most similar to your existing IT resources in your on-premise environment. Then we have Platform as a Service, or PaaS, which provides a complete development and deployment platform in the cloud for you to deploy your applications. In this cloud computing service model, cloud vendors provide developers with all the hardware and software environment required for building and deploying their applications and services over the internet. This helps you to be more efficient as you don't have to worry about resource procurement, capacity planning, software maintenance, patching, or any of that other undifferentiated heavy lifting tasks in running your application. Then we have software as a service, a cloud computing service model in which the vendor delivers you a completed product that is run and managed by the service provider so that applications need not be purchased, installed, and simply run on the user system. Now, SaaS users have to typically subscribe to the provider's software and access it using the vendor's API or the web. Then we have terms that we'll talk a lot about today: serverless computing. Serverless computing is a fully managed platform for providing compute, storage, and network resources without the need for you to provision or manage underlying infrastructure. We'll talk more about serverless technologies in the coming modules. A tech term that has gained much momentum over the past decade is big data, which describes large volumes of data in structured, semi-structured, and unstructured format that can be leveraged for gleaning valuable business insights using a number of techniques such as machine learning and advanced analytics. Big data is characterized by 4 V's: the volume of the data, the variety of the data, the veracity and the trustworthiness of the data, and velocity. So big data processing is all about turning this raw data into actionable information through the different techniques like analytics and machine learning. I hope you enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of the session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Thank you for attending this session. Please join us for our next session, Module 2, an introduction to compute, storage, and databases on AWS. data from anywhere. Amazon EFS and Amazon FSx are fully managed, cost-effective file storage. And finally, Amazon Elastic Block Store and easy to use. Amazon EC2. This allows us to select the operating system of choice and even have custom applications pre-installed to speed up deployment time. To summarize, EC2 provides you the flexibility to run your workloads when and how you want to. EC2 is what you make it. Example, a web server, or an application server, or a database server. Thinking of EC2 as disposable allows you to take advantage of pay-as-you-go pricing, significantly reducing your overall cost. There are a large number of EC2 instance types, which is great as it allows you to deploy the EC2 instance that will be most efficient and effective for your workload. The instance types are grouped into instance families, which make it easier to understand what each type is best used for, allowing you to make an informed decision. If you want to reduce the overall cost of your workload, then choose a general purpose instance. You need more compute grunt to help process application requests or batch processing quickly? Choose a compute optimized instance. If you need more memory to help speed up your database, choose a memory optimized instance. What if you're interested in machine learning, 3D modeling, or inferencing? Choose an accelerated computing instance. Each instance type also comes in different sizes, allowing you to be as cost efficient as possible while still getting your work done within your committed service level agreement. We previously learned that flexibility was a great benefit of EC2, and pricing flexibility is no different. With multiple pricing options to fit your workload and environment, we give you the options to make the decision and configuration that is right for you. On-demand instances can be considered the list price. With on-demand, you have the greatest flexibility and control over when and how you configure and deploy your instances. This is great for immediate scalability, workload changes, temporary workloads, or workloads that cannot be interrupted but required to be run only for a short amount of time. Reserved instances, on the other hand, give you a significant price reduction for workloads that run permanently. For example, you can choose a 1 or 3-year commitment, and the more you pay the commitment upfront, the bigger a discount you will get. Great for steady state workloads. Example, your public-facing website. Savings plan are a similar concept. You can commit to a certain amount of capacity that you are going to utilize over time. And lastly, and probably the most interesting one here, is spot instances, which gives you up to 90% of the on-demand pricing with one caveat. Spot instances are not guaranteed to run permanently. This means you need to be strategic about how you deploy them. However, they are great for ultimate cost reduction. As an example, most stateless applications can use spot instances and benefit from the lower cost. Another thing that's great about EC2 is the per-second billing with Amazon Linux, Windows, and Ubuntu, and per-hour billing with all other operating systems. This leads to granular billing, which is great for cost management. Another concept that I want to introduce here is the concept of unmanaged versus managed services. With unmanaged, you need to manage the scaling, the fault tolerance, and availability on your own within your application or architecture. Keep in mind, if you were running this application on premises, you'd be managing this anyway, including managing the physical infrastructure. But one of the key advantages to some of the services we're going to talk about here is that there's actually a managed, or in some cases, a fully managed option where you don't have to worry about the scaling, the fault tolerance, and the availability, which are built into the service itself. We're now going to shift gears a little bit and talk about serverless computing, which is something you may have heard of. EC2 is great. It's extremely powerful, configurable, flexible, and gives you control over your application and how it runs, but with that power comes responsibility. You still have to manage the fault tolerance, high availability, scalability, the operating system, application patches, access, permissions. It is a full server. But maybe you don't want to worry about the administrative side of compute. You just want to run some code. Maybe you have an application where some parts get run frequently and other parts not so much. Maybe you have ad hoc calculations that need to be run, or reactionary code that responds to events in your environment. Having a full server sitting there idle, waiting to be interacted with, is quite a waste of resources. So how can we do this better? We have serverless computing. With serverless computing, you have the ability to build and run applications and services without provisioning or managing the service that we just talked about. So we can still get the outcome of running specific code or function without having to manage all the underlying components. A key benefit here: no service to provision or manage, which leads to never paying for idle resources. So this is where serverless can greatly help us. If we can run our applications in a serverless manner, we can actually save by never paying for idle resources. So now that we've talked about what serverless computing is, let's talk about the heart of serverless technologies, AWS Lambda. AWS Lambda is a fully managed compute service which runs stateless code, supports multiple different programming languages, and can run your code based on a trigger or a schedule that you choose. This gives us some great benefits. Previously, we talked about EC2 instances, which required us to provision or choose the right type of instance to run our application, the network, and so on. With Lambda, we just need to add a code to something called a Lambda function and then tell it when to run. Lambda manages the execution and completion of the code. You don't have to worry about deploying the infrastructure or anything. AWS Lambda particularly excels at executing short-running, stateless code that has a defined start and finish. For code that runs indefinitely, you'll want to stick with something like EC2, but a little cloud design allows you to take advantage of what AWS Lambda has to offer. AWS Lambda also helps us to add automation into an environment, whether it's automatic logging, response and remediation, instant management, analysis. The list is just endless. Let's have a look now at an example of using AWS Lambda. We're we're going to have a basic scenario where a user could upload a picture to a storage location, in this case an S3 bucket. We'll learn more about that in the storage section coming up. We want to do some image recognition when the image lands in the bucket, so we invoke AWS Lambda to use an image recognition service when this occurs. So in this example, a user uploads a picture to S3, S3 triggers the Lambda, and Lambda uses another service to perform image recognition. Then it stores the results in a text file back in the S3 bucket. We call this an event-driven architecture where there are no active servers running. Let's take a look at how this is built. I'm going to be walking through an environment that has been pre-built to show you how it all ties together. We are now looking at the AWS Lambda dashboard in the AWS Management Console. From here, we can create a Lambda function. We're going to author one from scratch, give this a name of Awesome Image Recognition. We'll then select our favorite runtime. I'm happy with Python 3.9 and the ARM architecture. I'll then change my default execution role. This will give my Lambda function permission to access the images in my S3 bucket and to perform image recognition on them. So I will choose an existing set of permissions that I have already pre-configured. I'm now ready to create my Lambda function. Now that my Lambda function has been created, you'll see that I can edit my function code. It has some sample code for me to begin with. However, let's replace this by pasting in our own Python code. This code allows us to receive an image from an S3 trigger, perform image recognition, then store the results of it back in the original bucket as a text file. Once we've added our code, we can now save and deploy a function. I'll now navigate over to my S3 bucket. I'm going to edit its properties and add a trigger to invoke my Lambda function when I upload an image. I'm going to scroll over to Event Notifications, click on Create Notification and give it a name. I'll specify a .jpeg suffix so it only runs for JPEG files. I'll also make this only trigger on new upload events. And finally, I'll select my Lambda function we just created as the destination of the event. Now we'll click Save Changes and test it out. I'm back at my bucket, and now I want to upload a photo of a delicious pan pizza I cooked the other day. It's called lunch.jpg. I'll now drag and drop lunch.jpg into my bucket to upload it. Now that it's there, you'll see it listed inside my bucket. In the meantime, this will trigger my event notification to invoke my Lambda function and perform image recognition. When I click refresh, you'll see that the Lambda function has dropped our results as a text file in the bucket too. Let's download it and see inside. And finally, I can see that it has confirmed with 99% confidence that my pizza is in fact a delicious pizza. As we saw in this example, AWS Lambda enables you to create code blocks for easy development, testing, and deployment. AWS Lambda shields us from having to create or provision any virtual servers, unlike an EC2 instance, where the responsibility of provisioning and managing the virtual server is on us. There are many other serverless services within AWS that can be integrated together. Earlier we saw an example of event notification from S3. But let's see other applications and use cases for serverless. So in the example that we just saw with the Lambda, we were doing something very simple. But what if we wanted to create an entire backend? We can also do that in a serverless fashion as well. We can have many different Lambda functions and other services within AWS that will integrate with the Lambda so that we can create an entirely serverless backend. Maybe you're performing data processing or creating reports, maybe even having chatbots or other IT automation tasks, all serverless in the backend there, and we don't have any running or worst case idling resources. This is one of the key advantages of going down the serverless route. In some cases, you might not want to run a full EC2 instance 24/7 waiting for actions to occur. But what if you have a job or something that is going to take a short period of time, but maybe needs to run longer than it could within Lambda? Containers can really help us here. So what is a container? A container is a standardized unit that can package your application code and all its dependencies. The container can run on any operating system. With containers, applications can run the same on any machine without compatibility issues, with predictable behavior, and with more efficient maintenance and deployments. Containers give us a balance between the long-running compute that EC2 gives us, whilst being extremely quick to scale and run, which is where the Lambda excels. Amazon's Elastic Container Service, or ECS, is perfect for orchestrating the execution of your containers. This can be done on EC2 or even have ECS manage the infrastructure deployment for you. It maintains and scales the fleet of EC2 instances that run your containers and removes the complexity of standing up the distributed infrastructure. Typically, this is a complex activity because it requires determining where you might place those containers using a placement engine. In summary, Amazon EC2 enables us to launch as many or as few virtual servers or EC2 instances as you need, and enables us to scale up or down to handle the changes in requirements or spikes in traffic. Amazon ECS is a container orchestration service that gives us the ability to manage containers at scale on EC2. And finally, AWS Lambda is a compute service that lets you run code without provisioning or managing servers. Lambda runs your code on a highly available compute infrastructure. You only pay for the compute time that you consume when a request is made to your Lambda function. So we've spoken a lot about compute, EC2, Lambda, and ECS. Let's move on to storage on AWS. We have a number of different storage options depending on your application needs. Amazon S3, or Simple Storage Service, is a scalable, highly durable object storage in the cloud. We also have Amazon S3 Glacier for low-cost, highly durable archive storage in the cloud. And then we have Amazon Elastic File System, or EFS, a scalable network file storage service for multiple EC2 instances. We talked about hybrid cloud deployment in the previous module. With Storage Gateway, we have a hybrid cloud storage service that gives your on-premise environment access to virtually unlimited cloud storage. And then we have Amazon Elastic Block Store, or EBS, which we saw when deploying an EC2 instance. EBS volumes are network-attached volumes that provide durable block-level storage for EC2 instances. Lastly, we have Amazon FSx, which makes it easy and cost-effective to launch, run, and scale feature-rich, high-performance file systems in the cloud. Let's start with S3. S3 is an object-level storage, which means S3 manages the storage layer for you. S3 is designed for what we call 11 nines of durability. Durability is a measure of how likely you are to lose a file or an object. For example, if you store 10 million objects with Amazon S3, you can on average expect to incur a loss of a single object once in every 10,000 years. That's extremely durable. There is no limit to how much data you can store on S3. You can store as many objects as you like. However, each object cannot be larger than 5 terabytes in size. We previously saw an example of event triggers in the Lambda demo. This is a great feature of S3 that enables automation and designing event-driven architectures. S3 objects are stored within buckets, which are basically like containers that you create. You can also enable replication of objects between different buckets to create additional copies of the data within the same region, or maybe even to a completely different region if you need to. Then, similar to a pricing discussion before with EC2, you can also utilize different pricing models for storing your data, depending on different access patterns that you might have for your application. These are called S3 storage classes and range from immediate accessibility for hot data all the way through to archival options with long access times for cold or frozen data. Some example use cases for S3: content storage and distribution, backup and archival, storage for big data and analytics, disaster recovery, and static website hosting. In the introduction to the cloud, we spoke about AWS global infrastructure. One of the infrastructure elements that we talked about was a region, a geographical location. Now, it's important to think about which region to place your resources and store your data in. Generally, it comes down to 3 or 4 priorities. The first priority is data residency or compliance. If you have a regulatory or legal requirement that dictates where your data is kept, maybe it has to stay within the country it originated from, then you must choose the appropriate region. However, if this is not the case, then you have some flexibility to choose. Secondly, we want to locate the service as close to our customers who are going to be using it. This will help improve performance and give your customers a better experience. Third, it comes down to service and feature availability. Not all services are available globally, so sometimes you must choose a region that actually contains the service you want to use. Lastly, but by no means least, is the cost. Different regions have different prices. Sometimes choosing a different region can help you reduce costs on your workloads. Amazon Elastic File System, or EFS, provides serverless, fully elastic file storage so that you can share file data without provisioning or managing the storage capacity and performance, and it supports the Network File System version 4. With Amazon EFS, you can create a file system, mount the file system on an Amazon EC2 instance, then read and write data from your file system. We also have Amazon FSx, that allows you to choose between widely used file systems such as Windows File Server and Lustre, and delivering sub-millisecond latencies and high throughput. Amazon FSx for Windows File Server provides a fully managed shared storage built on Microsoft Windows servers backed by a fully native Windows file system. Amazon FSx for Lustre makes it easy and cost-effective to launch and run the popular high-performance Lustre file system for high-speed workloads such as machine learning, high-performance computing, video processing, and financial modeling. The last service we'll talk about in this section is Amazon Elastic Block Store, or EBS. We saw how this service was being used with EC2 earlier. It provided persistent block storage to our EC2 instances. EBS volumes come in a variety of different types with different underlying physical components. This allows you to apply an appropriate volume type to your workload. For example, if you're running a database that's reliant on low latency, random access, a provisioned IOPS solid-state drive may be perfect. However, if you're more interested in streaming large log files, then a throughput-optimized hard disk drive may be better suited. The volume types also let you reduce your cost of storage. EBS volumes also support snapshots, which are backups of your volumes. These snapshots are stored in S3 behind the scenes, so you get great availability and durability of your backups. Lastly, EBS supports at-rest encryption to keep your data secure. As we have seen, AWS provides a broad portfolio of storage solutions. We have object storage with Amazon S3 and Amazon S3 Glacier to store and retrieve any amount of data from anywhere. Amazon EFS and Amazon FSx are fully managed, cost-effective file storage. And finally, Amazon Elastic Block Store, an easy-to-use, high-performance block storage for both throughput and transaction-intensive workloads at any scale. Millions of customers use AWS storage services for a variety of use cases to help transform their business, increase agility, reduce costs, and accelerate innovation. Next up, let's talk about databases. Earlier, I introduced the concept of unmanaged versus managed services. While here, I want to talk about do-it-yourself databases versus AWS managed databases. You can definitely run your database of choice on an EC2 instance. There are a few valid use cases for this. Maybe you need access to the underlying operating system to install helper services, or maybe you need to use a database engine for legacy compatibility that AWS doesn't support. However, if you go down this path, you must manage high availability and fault tolerance, database backups, primary and secondary replication, operating system, and database engine patches. The administrative tasks are quite extensive. Running a database on an EC2 instance is an example of using an unmanaged service. You could instead choose to deploy your database into one of AWS's managed database services. Some examples include Amazon Relational Database Service, or RDS, for SQL-based databases, Amazon DynamoDB for NoSQL-based databases, Amazon Elasticache for in-memory caching, or Amazon Redshift for data warehousing. AWS has the broadest selection of purpose-built databases for all your application needs, and allows you to scale your largest and most complex workloads so that you can grow to reach more customers. Listed here are some examples of databases that could fill your needs. For example, we have relational databases that store data with a predefined table structure and relationships between them. They're used for traditional applications such as enterprise resource planning or ERP systems, customer relationship management or CRM systems, and e-commerce. We also have key value databases that are optimized for common access patterns, typically to store and retrieve large volumes of data. They are used for high-traffic website applications, e-commerce systems, and gaming applications. In-memory databases are used for applications that require real-time access to data. They are used for caching, session management, gaming leaderboards, and geospatial applications. Document databases are designed to store semi-structured data like JSON documents. They're used for content management, catalogs, and user profiles. When choosing a database, previously it was always, we have a SQL-compatible database. This is what we use, so this is what we will continue to use, even if the use case didn't fit. Now with the cloud, you have a plethora of database options to choose from. Our first choice must be whether you want a SQL-based database or a NoSQL-based database. SQL databases are great when needing to join tables, needing to perform complex analytical queries, or to have flexible yet complex querying. Maybe you know what your data looks like, but you don't know how you want to query it. NoSQL databases, on the other hand, can be extremely fast and provide low latency responses. They support flexible, ad hoc data structures and can scale differently to a traditional SQL-based databases. So how do you choose? For a relational style database that has transactional requirements, look no further than Amazon Relational Database Service or RDS. If you need a relational style database but require analytical processing, then Amazon Redshift is your service. For storing your data in a non-relational way for transactional databases, Amazon DynamoDB may be a good fit for those needs. But you might also have the need for a graph database, which is more focused on the relationship between data points rather than the data points themselves. You can use a graph database for fraud detection, recommendation systems, and Amazon Neptune is your graph database. Lastly, we have Amazon Elasticache, which provides a caching solution, and it's available with two popular caching engines, Redis and Memcached. This is only a sample of databases on AWS, but regardless of your application needs, there is a purpose-built option that you can migrate to or stand up in the cloud. So first up, we have Amazon RDS. RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while managing time-consuming database administrative tasks. And that frees you up to focus on your application and your business. RDS supports 6 familiar database engines that you can choose from, including Amazon Aurora, which we'll talk about, Oracle, Microsoft SQL Server, PostgreSQL, MySQL, and MariaDB. Amazon RDS also provides a number of features that make it easier to manage common database tasks. Once you've created your RDS database, you can configure automatic backups and maintenance windows while working around your application traffic. By default, Amazon RDS enables automated backups of your database instance with a 7-day retention period. RDS also gives you the ability to run your database instance in a multi-AZ deployment, which increases the fault tolerance by maintaining a synchronous replica for automatic failover. Lastly, you can scale the compute resources and storage capacity needed for your database over time as your data or your demand for your database grows. We've also got Amazon Aurora, which is MySQL and PostgreSQL compatible relational database built for the cloud. It combines the performance and availability of high-end commercial databases with the simplicity and cost-effectiveness of open-source databases. Aurora is built for high availability and durability, concepts that we are familiar with so far. It's also built for high performance, scalability, whilst providing multi-regional capabilities. There are also some neat features of Amazon Aurora that sets it apart from other relational databases. Aurora has a distributed, fault-tolerant, and self-healing storage system. The data blocks are continuously scanned for issues and repaired automatically. You can utilize up to 15 read replicas on Amazon Aurora across multiple AZs, which share the same underlying storage volume as the primary database instance. This enables really great read scaling and high availability for your applications. Another great feature is Amazon Aurora Serverless, which provides on-demand access to your data with automatic startup, shutdown, and scaling. This is another great option to save costs on those unpredictable or spiky workloads. The last thing to mention here that's important about Aurora is that Aurora is up to 5 times faster than standard MySQL databases at a tenth of the cost. Next up, we have Amazon DynamoDB, which is a fast and flexible, non-relational database service for applications that need consistent single-digit millisecond latency at any scale. The fully managed nature of DynamoDB makes it really flexible for many different use cases, but also takes away a lot of the management tasks. DynamoDB handles all the partitioning of data in your table, so you don't have to worry about managing those different partitions yourself. You also get fine-grained access control with identity and access management. And since there's no underlying instance to manage, you configure the read and write capacity for your DynamoDB tables, ensuring that your application has the right throughput. Where you might have spiky workloads, DynamoDB features on-demand and adaptive capacity options help you with those spiky workloads. In most cases, DynamoDB offers a single-digit millisecond response time, but sometimes your application may need an even faster response time. In those cases, we have something called DynamoDB Accelerator, or DAX for short, which is an in-memory, API-compatible cache that reduces response time down to microseconds. Lastly, DynamoDB provides the ability to create a multi-region, a multi-active configuration with something called as DynamoDB Global Tables, and that frees you from having to roll your own replication solution. An example of a DynamoDB use case, companies in the gaming vertical Use DynamoDB in all the capabilities of game platforms, including storing the game state, player data, session history, and leaderboards. So in summary, AWS provides over 15 purpose-built engines to support diverse data models, including relational and non-relational solutions to enable customers to build use case-driven, highly scalable applications suited to their specific needs. NoSQL databases are purpose-built for specific data models and have the ability to support a flexible schema for building modern applications. NoSQL databases are widely recognized for their ease of development, functionality, and performance at scale. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of this session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Why not test your knowledge and make sure you complete the knowledge check after the session to see how you're progressing? Thank you for joining us in the session. Join us for our next session, Module 3, on networking and security. Thank you. consent if necessary. Hello and welcome to Awesome Day 2023. My name is Aarti and I have the pleasure of being your AWS technical trainer for this next session, Introduction to Networking and Security. So if you're new to AWS or just looking to learn more about networking and security in the cloud, you are in the right place. So jumping right in, let's talk about networking. At the heart of networking in AWS is Amazon Virtual Private Cloud, or VPC. VPC is a service that allows you to create your own private space within the AWS cloud, a logically isolated virtual network that you define. You can use VPC to logically separate your workloads, whether you're isolating your development, test and production environments, or separating differing functions due to security concerns. VPC helps you control the flow of your traffic. VPC, like most other AWS services, is logically defined. Therefore, you can deploy as many VPCs as you need for your particular use case. It is not uncommon for larger, more complex environments to have hundreds of VPCs. Ultimately, it gives you control over the network access to your workloads, whether that be public access to the internet or private access only to your on-premise or corporate environment. When deploying a VPC, the first thing we need to do is to allocate a range of IP addresses. We can then further partition the VPC into smaller networks called as subnets. This allows us to break our VPC into segments which we can use for high availability or security or apply different levels of control. For example, here we have two types of subnets, public and private. The public subnets can be accessed via the public internet. Now you might just want to have a public-facing web application here, or maybe a bastion or a jump host. We also have private subnets which do not have direct public internet access. This means they are protected from bad actors on the internet trying to compromise your application. This lets you place your backend systems such as databases or application servers in the private subnet with no internet access. VPC is what we call a regionally scoped service, meaning it sits across all availability zones within the region. Subnets are availability zone scoped, meaning they'll sit in individual availability zones. However, you can have multiple subnets in different AZs in a single VPC. You can have multiple VPCs within the same region or different regions for that matter. However, you cannot have a single VPC span multiple regions. So now that we know more about subnets, let's talk about how we can take advantage of the different VPC features to achieve a defense in-depth approach. When we design our infrastructure, we can achieve defense in depth. What this really means is that we have multiple layers of protection across the configuration of your VPC. Within your VPC, you can use these multiple layers of security, including security groups, network access control lists, and route tables to help control access to Amazon EC2 instances in each subnet. Firstly, we have an internet gateway that enables the resources in your public subnets, such as EC2 instances, to connect to the internet if your instances have a public IP address. Then we have the route tables. Route tables contain a set of rules called routes that are used to determine where the network traffic is routed. Using the route tables, we can protect our workloads to not allow public internet access or to restrict to outbound requests only. For the public subnets, the route table must have a route that directs the internet-bound traffic from your EC2 instances to the internet gateway. Next, surrounding the subnets, we have network access control lists. These are stateless packet filters that wrap around the subnet and determine whether traffic can enter or leave. These are great for providing explicit block rules to known problem areas or restrict specific protocols or port numbers. Next, wrapping around the EC2 instance is the security group, which acts as a stateful packet filter or firewall controlling the inbound and outbound traffic at the instance level. By default, all traffic inbound is blocked while all traffic outbound is allowed. Lastly, on your EC2 instance itself, you can install your own firewall and protection software. In this demo, I will show you how to deploy a photo sharing website using Amazon S3, Amazon DynamoDB, and Amazon EC2. This demo will give you a holistic view of architecting an end-to-end solution by integrating the different AWS services we have talked about today. Let me walk you through the core architecture of the solution. First, our photo sharing website is deployed to a web server hosted on an EC2 instance. For this demo, I will act as the user who will upload an image through the website interface. The web application receives it and creates a thumbnail of the image. It then uploads the source image and the thumbnail to the S3 bucket and inserts the image metadata into the DynamoDB table. For the purposes of this demo, the media content is limited to images, but the concepts covered here can easily apply to other types of media content. Let's now build our demo. The first task is to create an S3 bucket to store the media contents and configure its permissions. At the top of the AWS Management Console, in the search bar, search for S3 and choose S3 from the drop-down. This takes us to the S3 dashboard. Choose the Create Bucket and configure the bucket name, something like ANMyBucket 2023. By default, content stored in Amazon S3 buckets cannot be accessed publicly. For our use case, we need to allow public access to the bucket so users can download content. So under the block public access settings for this bucket, deselect the block all public access. Acknowledge the security warning by selecting I acknowledge that the current settings might result in this bucket and the objects within becoming public. Scroll down and choose Create Bucket. While we want to allow downloads from the bucket, we don't want to allow users to list the contents of the bucket or delete any objects. Amazon S3 enables you to manage access to the objects and the buckets using bucket policies to configure permissions. We will now go ahead and create a bucket policy to configure the permissions for our S3 bucket. In the list of buckets, we choose the name link for the bucket that we just created. Choose the Permissions tab. In the Bucket Policies section, choose Edit. I will now copy a policy document and paste it in the policy pane. Choose Save Changes. We have now created an S3 bucket to store the media contents and configure its permissions. Next, let's create the media database to store the metadata information for our media files, such as the title, the comment, the publication date. Since we want our system to be scalable, we will use Amazon DynamoDB to store the metadata information. At the top of the AWS Management Console, in the search bar, search for DynamoDB and choose DynamoDB from the drop-down list. Choose the Create Table, then configure the table name as My Table, the partition key as EIB, and click on Create Table. The table we created is listed under the Table section and its status displays as Creating. The next task is to create our web server and deploy our photo sharing website to the web server. But before we launch the EC2 instance, we need to create a basic Amazon Virtual Private Cloud, or a VPC. This VPC will be used to launch our EC2 instance. So in the AWS Management Console, in the search bar, type VPC, select VPC from the drop-down menu. We're now going to create a VPC with a single public subnet. The web server will be hosted in the public subnet so that it can reach the public internet. In the left navigation pane, choose your VPCs, choose Create VPC, and then configure the options. We're going to choose VPC only. I'll give this a name, Awesome Day VPC. Now the first thing we need to do is to allocate an IPv4 CIDR block as 10.0.0.0/16. Choose Create VPC. Our VPC has now been created. The next step is to create a public subnet. Next, in the left navigation menu, choose Subnets. Choose the Create Subnet and then configure the VPC ID as the Awesome Day VPC that we just created in the previous step. Give a public subnet a name, Public 1. For the availability zone, select the first AZ in the list. And for the IPv4 CIDR block, choose 10.0.1.0/24. Now scroll down and choose Create Subnet. Next, select the subnet we just created, namely the public one. In the Actions menu, select the Edit Subnet settings and then configure. Select Enable Auto-Assign Public IPv4 Address. Now, enabling this auto-assign public IPv4 address, it provides a public IP address for all the instances launched into the selected subnet. Choose Save. Now, even though your subnet is now labeled as Public 1, it's not yet a public subnet. A public subnet must have an internet gateway attached to it, which we will create in the next task. In the left navigation pane, choose Internet Gateways, choose Create Internet Gateway, then configure a name for the gateway. Let's call it My IGW. Choose Create Internet Gateway. In the Actions menu, select Attach to the VPC and then configure from your available list of VPCs. You're going to choose the Awesome Day VPC. And we're going to choose Attach Internet Gateway. This is now attaching the Internet Gateway to the VPC that we just created. Now, even though we've created an Internet Gateway, attached it to our VPC, we still have to tell our instances within the public subnet how to get to the Internet. So in the next task, we're going to create a route for the Internet-bound traffic. For this, from the left navigation pane, let's choose the route tables. We can see that there is currently one default route table associated with our VPC, the Awesome Day VPC. Within the Routes section, in the lower half of the page, notice that there is one route in your route table that routes the traffic locally. That is, it allows the traffic within the 10.0.0.0/16 network to flow within the network, but it does not route the traffic outside of the VPC network. We will now add a new route to enable public traffic. For this, choose Edit the Routes. Next, add a route, then configure the destination as 0.0.0.0/0. Choose the target as the Internet Gateway, and in the drop-down box, select the displayed Internet Gateway ID that you created in the previous step. Now choose Save Settings. Next, choose the Subnet Associations tab. Under the section Edit the Subnet Association, choose Edit Subnet Associations. Select our subnet Public 1 and choose Save Associations. And now our subnet is public because it's connected to the Internet via the Internet Gateway through the route in the route table. The next task is to add a security group so that users can access your web server via HTTP. Now, we discussed earlier that a security group acts as a firewall for your instance to control the inbound and outbound traffic. Again, from the left navigation pane, we're going to choose Security Groups. Choose Create Security Group. Give the security group a name. Let's call it Web Server Security Group. The description, allow HTTP traffic, and choose our VPC, which is our Awesome Day VPC. And under the inbound rules, choose Add a Rule. The type is HTTP and the source is traffic coming from anywhere. Scroll to the bottom of the screen and choose Create Security Group. The security group is now successfully created. When we launch an EC2 instance in the next task, we're going to associate this security group to the EC2 instance. Moving on to the next task. Again, from the AWS Management Console, using the search bar, let's search for EC2 and select EC2 from the drop-down menu. From the left-hand side menu, select Instances and then choose Launch Instance. From here, we will go through and configure the launch details of my new instance. I'll give this instance a name, which will be my photo sharing website or my website. Next, select the Amazon Machine Image or AMI, which provides the information required to launch an EC2 instance, such as the operating system. Notice that we have a quick start here. The quick start list contains the most commonly used AMIs. You can also create your own AMI or select an AMI from the AWS Marketplace, an online store where you can sell or buy software that runs on AWS. In this case, we'll choose the latest version of Amazon Linux 2. Next, we're going to select the instance type. Since this is a simple web application, we will choose an instance type that is most appropriate for a simple, typical web server. We will go with T2.micro, which has one virtual CPU and 1 gigabyte of memory. In the key pair section, locate the key pair name drop-down menu, and we will choose Proceed without a key pair. Now, something to note here, Amazon EC2 uses public key cryptography to encrypt and decrypt login information. To log into your instance remotely, you normally require a key pair, and when you log in, you specify the name of the key pair when you launch the instance and provide the private key to connect to the instance remotely. However, in this example, we will not be connecting remotely to the instance, so we don't require a key pair. Next, in the networking settings section, choose the Edit button. Make the following selections. We're going to choose the VPC with the name that contains the Awesome Day VPC. For the subnet, we're going to choose a public subnet 1. In the firewall security group section, we're going to choose a security group that we created, the web service security group. Next, we configure the storage section. We can leave the default choices in here and for all the remaining configuration settings. Now, Amazon EC2 stores the data on a network-attached virtual disk called the Elastic Block Store. You will launch this Amazon EC2 instance using a default 8 gigabyte disk volume. This will be your root volume, which we also refer to as a boot volume. Next, expand the Advanced Details section, scroll down to the IAM instance profile, and in the drop-down menu, choose the Amazon SSM Managed Core role. Now, I've pre-created this role, and this role is simply associated with IAM policies that grants any application running on this EC2 instance, giving it permissions to access both Amazon S3 and Amazon DynamoDB. Next, scroll down to the Termination Protection drop-down menu and set it to Enable. Now, this is going to prevent your instance from being accidentally terminated. Scroll all the way down to the bottom until we see a field called User Data. Now, when you launch an EC2 instance, you can pass the user data to the instance, and that can be used to perform common automated configuration tasks and even run scripts after the instance has been launched. Your instance is running an Amazon Linux, so you will provide here a shell script that will run when the instance starts. I'm going to copy a pre-written script and paste it into the user data field. Basically, this script initializes a Ruby on Rails environment for the application that's going to be deployed on this EC2 instance. Then I'm going to deploy the web application to the initialized environment and then activate the web server. We've now done all the configuration and we can choose Launch an Instance. Choose View All Instances from the bottom of the page. This takes us back to the EC2 Instance dashboard. And you can see that the instance that you just launched might appear in a pending state, which means that it is just being launched. It will soon change to running, and that indicates that the instance has started the process of booting up. Now, when creating a new instance, there will usually be a short time before you can access the instance. Wait for your instance to display the instance state as running and shows a status check as 2x2 checks passed. Okay, so now our EC2 instance has been successfully launched. Let's go ahead and test our deployment. Let's select our newly created instance. And from the Details tab in the bottom section of the page, we can see the detailed information about your instance. We can see the instance type, the security settings, the network settings, and more. Let's locate the public IP address value and copy it to the clipboard. Let's open a new browser tab and paste the public IP address into the address bar and press enter. We can see that our photo sharing website has been successfully launched. Let's now add an image to the application by choosing New, then providing a title, description, and tags. Add the image file and choose Create a Flick. Let's jump across to the DynamoDB dashboard. From the left navigation panel, choose Tables, choose My Table, choose Explore the Table Items, and we can see that the metadata of a media file is now, as stored by the web application, is now in the DynamoDB table. We can also check how the media files have been stored in the Amazon S3 bucket. Let's quickly navigate to the S3 dashboard, choose the name link of our bucket that we created, ANMY bucket 2023, and we can see the list of image files uploaded by the application in the bucket, along with the thumbnail image that you can recognize with the tn.png extension. Congratulations, we have successfully deployed and tested our web application. In the above solution, we have seen how to deploy a photo sharing website using Amazon EC2, Amazon DynamoDB, and Amazon S3. While Amazon S3 and DynamoDB are both scalable and fault-tolerant systems, the web application running on a single EC2 instance is clearly a single point of failure. If the web application fails, the system is not accessible and cannot recover and remains a bottleneck. With a large number of load incoming requests, the system might even become unavailable. For better resilience, we could have built the same example, employing an event-driven architecture, making use of Amazon S3, Amazon DynamoDB, and using AWS Lambda as the compute service in place of EC2. Okay. In a small environment where you have a low number of instances, maybe one or two instances, the traffic distribution is not going to be a problem. But what happens when you want to scale that out or have dynamic scaling that changes depending on how much load is currently being produced? we need a more sophisticated load distribution method. Introducing Amazon Elastic Load Balancing Service, or ELB. Amazon ELB comes in multiple flavors, but the key here is the application load balancer that distributes traffic according to HTTP or HTTPS rules that you configure. Elastic load balancers are highly available and can be used to decouple application tiers. This means your web tier doesn't need to be aware of changes to the app tier infrastructure. It also supports health checks. So if instances behind the Elastic Load Balancer fail, or maybe your application stops responding, the ELB can actually determine that a particular instance has failed. It will then stop distributing traffic to that failed instance, resulting in a better experience for your customer. Then finally, we also get security features within the Elastic Load Balancer. We can utilize TLC termination on our Elastic Load Balancer to unburden our instances behind the scenes. Now, the Elastic Load Balancer is regionally scoped. It gives us the ability to distribute incoming traffic to multiple instances or applications across multiple AZs within the region. But what if we want to distribute traffic across multiple regions? Amazon Route 53 gives us that capability to do that on a global scale. Amazon Route 53 is a highly available and scalable cloud DNS service. You can use it to register domain names and even perform automatic renewals or configure different routing options which allow us to determine where the traffic should go. It provides tools for flexible, high-performance, highly available architectures on AWS, and we have multiple routing options. Let's see how this works. In this particular example, we might have a client or an end user that's trying to connect to our application that is sitting within our VPC. The end user would navigate to our website URL. Route 53 would then be used to resolve that URL into an IP address, which then leads us through our internet gateway to our Elastic Load Balancer, which then distributes the incoming traffic to the multiple EC2 instances sitting behind the load balancer, which then correspond back to the user. And we're doing this all within our VPC within the AWS cloud. Amazon VPC also offers connectivity over VPN or using another service called as Direct Connect, which allows you to connect to your VPC from your on-premise data center, offices, or other customer locations in a secure manner. In addition to these hybrid connectivity options, VPCs can also be connected to each other through a mechanism called VPC peering, and these VPC peering connections can span multiple regions. So we have the ability to peer VPCs together to expand our environment if necessary. Okay, so in summary, we have learned that Amazon VPC allows for the creation of logically isolated network to launch applications. Within your VPC, you can use multiple layers of security, including security groups, network access control lists, and route tables to help control access to Amazon EC2 instances within the subnet. Finally, for hybrid networks, AWS offers different connectivity options such as site-to-site VPN and Direct Connect to connect your on-premise data centers to the VPC in the cloud. We'll now change directions and talk about security. At AWS, cloud security is our highest priority. As an AWS customer, you will benefit from a data center and a network architecture that is built to meet the requirements of the most security-sensitive organizations. The AWS infrastructure has been architected to be one of the most flexible and secure cloud computing environments available today. A key way to look at security on AWS, especially as a customer, is using this shared responsibility model. When you think about security in your on-premise environment, well, you need to manage everything, from the physical security of the building to the physical security of the IT devices, through to environment controls, operating system, application, data, etc. This results in a considerable amount of administrative overhead without much benefit added to your business. We previously talked about the term undifferentiated heavy lifting, which referred to running the physical components of the data center. When deploying resources on AWS, we learned that the AWS took care of this undifferentiated heavy lifting. That is, AWS will manage all that physical stuff for you. This means that AWS has some responsibilities in keeping the cloud secure. On the flip side, AWS does not have access to your data. We also don't have access to the resources you deploy. So there will be an element of responsibility that falls onto you as a customer. And this is where the shared responsibility model comes in. It details and highlights what is AWS responsibility and what is your responsibility. Let's take a look at two simple examples. Firstly, when using EC2, it is AWS's responsibility to provide physically secure compute servers that are made available for use. But then, when you deploy on an EC2 instance, it is your responsibility to apply ongoing operating system patches. It is the responsibility of AWS to provide the ability to encrypt your EBS volumes. However, it is your responsibility to actually enable the encryption. We don't mandate how you must perform something. We provide you the options, the levers, and controls. In a separate example, let us look at S3. It is the AWS responsibility to provide a highly available and durable storage solution for you to use. It is the AWS responsibility to provide a permission structure that restricts public access. However, it is your responsibility as a customer to determine what data resides in S3, whether you want this data to be encrypted or not, and which identities have access to it. In short, AWS is responsible to provide a robust and secure cloud framework, a framework that provides you, the customer, the ability to operate safely and securely. But it is your responsibility to make use of this configuration options, the levers, and the controls to appropriately decide which data can reside where, and then to make informed decisions on how to deploy your services. Every service in AWS falls into the shared responsibility model. Some services are going to require more responsibility from you as the customer, whilst others require less. There are many services that can help you manage your security, from encryption to key management to web application firewalls, logging and monitoring, just to name a few. Let's now talk about how we can use the AWS service, Identity and Access Management, or IAM, to authenticate users and control their access to the different AWS services and resources. AWS IAM gives you the ability to securely control access to your AWS resources. You can assign granular permissions to users, groups, and roles. You can share temporary access to your AWS account and also federate users from your corporate network or with an web-based identity provider. Let me now take you through some whiteboarding to understand the core components of IAM. AWS Identity and Access Management, or IAM, is a service that helps you to securely control access to AWS resources. You use IAM to control who is authenticated or signed in and who is authorized or has permissions to use the AWS resources. Authentication is establishing the identity of the caller accessing the AWS resource. And in AWS, we refer to this caller as a principal. Authorization is establishing the permissions of the authenticated principal. What can they access? A principal in IAM can be a single IAM user. Let's call our user Shirley. Or it can be an IAM group. Here we have a group of users, Shirley, Bob, and Mary, belonging to the group developers, or a principal could also be an IAM role. Now, an IAM user is a permanent identity. You create it and the credentials will stay until you choose to remove them. There are two ways a user can authenticate via a username and password to log into the graphical AWS Management Console, or via an access key ID and secret access key through the CLI or SDK. Now, when we create an AWS account, we begin with one sign-in identity that has complete access to all AWS services and resources in the account. This identity is called the AWS account root user, and this user is the first user which we refer to as the root user. Now, here are some key AWS security best practices. First and foremost, enable multi-factor authentication on the root user credentials. And do not use the root user credentials for your everyday tasks. Instead, logged in as the root, create an administrator user with the star privileges, and then use the administrator user to perform your day-to-day tasks. We do this to safeguard the root user credentials. Now, an IAM role, on the other hand, is a temporary identity which can be assumed for a short period of time, after which it will automatically expire. Now, when you assume a role, you are granted a temporary set of access keys that have a defined expiry period. Roles are extremely powerful and allow you to create identity federation, where you can create a single sign-on experience for your users or even customers. Using roles, IAM could be used to grant the employees in your organization and applications federated access to the AWS Management Console and the AWS Service APIs by using your existing identity systems, such as the Microsoft Active Directory or an LDAP identity store. Now, in AWS, we talk about implementing the principle of least privileges, which is all about granting users just the right amount of permissions they need for the AWS services and resources they need to access. permissions are granted to a principal using policies. Now, when the authenticated principal requests to perform an action, example, view an object in the S3 bucket, the policies enforced on the principal are evaluated to check if the principal can perform the requested action. Now, in AWS, a policy is a JSON formatted document that allows you to grant or deny actions. Actions are basically the REST API calls that are made to access your resources. Let's take a look at what a policy looks like. Now, each policy statement in the policy document, it consists of three key elements. The E stands for effect, which can be an allow or deny. The A stands for action, the specific REST API call, example, the getObject API call on the S3 bucket. And the R stands for resource, the AWS resource that you want this particular policy to be applied on. For example, let's create a policy statement where the effect is allow, the action is start instances, and the resource is EC2 star, meaning all the EC2 instances. Let's call this policy the EC2 launch policy and attach this policy to our user, Shirley. Let's go ahead and create a second policy that allows access to all API calls on the EC2 web service on all the EC2 instances. We're going to call this the EC2 admin policy and attach this policy to our developers group. So, my question to you, what is the net access control for Shirley? Well, Shirley is firstly able to launch any EC2 instance because of the EC2 launch policy, but as Shirley is also a member of the developers group, which has the EC2 admin policy attached to it, Shirley can invoke any action or any API call on the EC2 service. The policies we just created are called as identity policies, as these policies can be attached to different kinds of principals, which can be a user, a group, or a role. Well, that's a quick overview of AWS IAM. We previously talked about using Amazon S3 for object storage. S3 is an example of a service that can have a resource-based policy attached to the bucket. In this case, we call that a bucket policy. A resource-based policy is just another type of IAM policy that is attached to the resource, such as an Amazon S3 bucket, and these policies grant permissions to the principal that is specified in the policy. Let's look at this example where you've created a new bucket. The default access configuration blocks all access other than the owner who created the bucket. But maybe you want the ability to grant permissions to everyone to make it public. This is useful if you have content that you want to share publicly, like our photo sharing website. But what if you want to just grant permissions to specific users or services, or maybe a subset of users, roles, or services? Bucket policies, along with identity policies that we spoke about previously, allow granular control over who or what can access your resources, from where and when. Another way we can ensure the security of our data is to utilize various forms of encryption on objects in a bucket. S3 offers server-side encryption known as SSE on the object stored in the bucket, and you can do this encryption either by using a customer-provided encryption key, a key managed through the key management service, AWS KMS, or have the S3 service itself manage the encryption key. Using these forms of encryption enables S3 to encrypt your object when the data is at rest. S3 also supports the HTTPS protocol, which enables encryption in transit. Moving on to our next service, AWS CloudTrail. AWS CloudTrail is an example of a service that we can use for security auditing in our AWS account. CloudTrail enables us to track identity activity and API usage in our accounts. We can continuously monitor activities and record API calls against multiple different services in our account. We can use this for compliance, auditing, security analysis, and also for troubleshooting purposes. We can also use this to record in case we need to backtrack and understand how the access was granted. The API calls are stored in a trail, essentially a log file. These trails can also be exported to our S3 bucket that we talked about earlier. And so, by keeping all that information, we have the ability to answer common questions from a security standpoint about who made a request, what did they request, when did they make that request, and from where were they requesting. So CloudTrail gives us the transparency in our account. Additionally, storing the CloudTrail logs into S3 allows us to reduce the cost of storing that important log data and also grants us the ability to use various querying tools such as Amazon Athena, a serverless SQL querying tool. The last service I want to talk about in this session is AWS Trusted Advisor. Trusted Advisor is a tool that sits in the background of your account and provides guidance on how to improve your account across various pillars like security, performance, fault tolerance, and cost optimization, along with identifying any service limits you are approaching or might have hit. Trusted Advisor bases its guidance on the AWS well-architected framework, a series of best practices compiled by AWS architects to help build effective architectures. So how does the Trusted Advisor work? Let's take an example of cost optimization. Imagine you have a large EC2 instance, an M5 4 extra large, and that has been operating at 10% utilization over the last month. Trusted Advisor may look at this and say, well, you can reduce the size of this instance and still meet your performance objectives, and it will cost you less so you can achieve some savings. On a separate note, maybe you have all of your EC2 instances in a single availability zone. If that availability zone were to have an issue, you could potentially lose your entire environment. So Trusted Advisor will give you a warning under the fault tolerance category, suggesting that you deploy your resources across multiple availability zones. There are many checks that Trusted Advisor performs, which are regularly refreshed to give you updates as changes to your account and environment are made. So summarizing what we have learned in the security module. Security is a shared responsibility between AWS and the customer. Customers should carefully consider the services they choose because their responsibilities are going to vary depending on the services used. We also talked about AWS IAM that enables us to implement a fine-grained access control to AWS services and resources. We talked about AWS CloudTrail, an AWS service that records actions taken by a user, a role, or another AWS service as events. Finally, we learned that AWS Trusted Advisor evaluates your account and provides recommendations that help you to optimize your AWS infrastructure, improve security and performance, and reduce costs. I hope you've enjoyed this session and found it interesting. AWS is a data-driven company, and I'd like to take this opportunity to ask you to complete a survey telling us what you thought of the session. This can help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on the slide. Why not test your knowledge and make sure you complete the knowledge check after the session to see how you are progressing? I would like to thank you all for attending this session. Next up, join my colleague Jack for Module 4, Innovation with AWS.
Hi, my name is Jack Romanos, and I'm a technical trainer here at Amazon Web Services. My job is to teach people about AWS services to help them to learn, upskill, and certify in cloud technologies. We are very glad to have you join us today at Awesome Day Online Conference. In Module 4, we're going to take a look at innovation with AWS. We have 5 key components to discuss in this section. We're going to talk about IoT or Internet of Things on AWS, machine learning, blockchain, AWS Ground Station, and AWS Wavelength. With technology as the enabler of innovation, AWS is your trusted advisor, uniquely positioned to help your organization shift to an operating model optimized for innovation. We'll start off with IoT, or Internet of Things. What is Internet of Things, or IoT? IoT is where a system of integrated devices, such as appliances, watches, features in a car, or even toasters, can be connected to various applications. These connections enable the data to be transferred to and from devices in bidirectional communication flow over a network. That telemetry data can actually be collected and captured from various embedded sensors, microcontrollers, actuators, processors, and communication hardware that is in the surrounding environment. Automating data collection can reduce the need for human-to-human or human-to-computer interactions. With the number of devices that we have today, and billions of IoT devices coming online, there are some inherent challenges with managing large fleets of these things. First of all, are the overall updates. We've got devices with firmware, we have microcontrollers and sensors that have very lightweight firmware and need hardware that we need to be able to keep updated or in sync. Sometimes there are issues with network connectivity. These sensors or devices can be on ships or on various different moving objects where they don't consistently have stable internet connections. The second issue that could arise is that because these devices are remote, they might not be physically accessible. They may be built into equipment, so we may not be able to readily connect wires to them and update them. And lastly, we might have potentially large fleets of devices in production that we have to manage. How do we manage all the communication to and from the sensors and maybe between the various sensors? Also, from an analytics standpoint, we might have very low compute power, maybe low spec on-device resources. In that case, we may not be able to do calculations or analytics on board directly on the device. But these devices may also emit very large volumes of streaming data that we need to analyze at a later point. The question is, how do we actually get that data out? How can we manage all these remote devices from the remote standpoint? AWS has IoT services for many of these areas that we just talked about. If you need to take data off those devices, stream them into a central location, and analyze them, we have solutions like AWS IoT Analytics, IoT Events, and IoT Things Graph. From the standpoint of managing device software, we have FreeRTOS, IoT Device SDK, IoT Greengrass, and IoT Device Tester. And then finally, to actually connect and control these various different devices and provide services that allow us to be able to manage the messaging and communication between these different devices, we have IoT Core, IoT Device Management, and IoT Device Defender. Customers in various industries are using AWS IoT in applications for improving industrial processes. An example would be remote patient health monitoring solutions that enable healthcare providers to remotely monitor the status of a connected sensor. Measuring and collecting field, crop, and ambient data are key capabilities enabled by AWS IoT solutions. IoT is used for connected vehicle and autonomous driving capabilities too. AWS IoT makes it easy for you to build, scalable IoT applications that collect, process, analyze, and act on data generated by connected home devices without having to manage any infrastructure. AWS IoT Core can use AWS services as building blocks to set up a secure and powerful IoT deployment. With AWS IoT, you can build solutions that help you respond to events in near real time and reduce your concerns about scale, enabling you to focus more on your core business. As you can see here, AWS IoT is connected to multiple different AWS services, some of which we've talked about already today. AWS Lambda to run your business logic, DynamoDB for your database layer. You can build IoT applications that gather, process, analyze, and act on data generated by connected devices. AWS IoT Greengrass is an Internet of Things or IoT open source edge runtime and cloud service that helps you to build, deploy, and manage IoT applications on your devices. It enables your devices to act locally on the data that they generate, run predictions based on machine learning models, filter, and aggregate device data, thus saving you time, especially in cases where milliseconds matter. In farm fields across the globe, Bayer Crop Science is planting and harvesting seeds to help farmers improve global food systems. Bayer Crop Science uses AWS IoT for collection, processing, and analysis of seed growing data. This solution captures terabytes of data and enables analysts to pull up dashboards from the collection platform. Using AWS IoT, visibility into field conditions is more readily accessible and the data can be analyzed much quicker. Now, let's talk about machine learning on AWS. First of all, what is machine learning? Using technology to discover trends and patterns, compute mathematical predictive models based on factual past data, build learning models, and make predictions. Starting off with artificial intelligence. It includes really any technique that enables computers to be able to mimic human intelligence. This could be a simple OR logic, an if-then statement. It can be programmed by hand too, as it mimics human intelligence. A subset of that is machine learning, which utilizes machines and lots of data to search for patterns in that data and build logic and models automatically. Essentially, with machine learning, we have a machine that learns based on patterns in the data or come up with its own paradigms and discover its own patterns in that data. Another subset of machine learning is deep learning. This uses a multi-layered approach to perform tasks like speech and image recognition. That often requires lots and lots of data and many more features. Let's dive a bit more into machine learning. Amazon itself is an example of a company that went through a multi-year machine learning journey in order to be ML driven, like the company you see today. Amazon had been applying ML in areas such as personalization and supply chain for more than 20 years. ML is an integral part of Amazon. We've improved that original personalization model significantly over time and moved it to other products such as Amazon Prime. We use ML throughout our fulfillment process, including the development of a forecast system that can predict the appropriate amount of demand for each product we sell worldwide. In order to deliver on our customer expectation on convenience, cost, and delivery speed, we've developed natural language processing technology to give consumers an entirely new way to interact with technology through Alexa. We've also developed groundbreaking technology with autonomous flight via Prime Air drones and using robotics in our fulfillment centers to get packages to consumers faster. This was a big cultural change for us, but it's something every organization can do. Within AWS, we see the machine learning and AI services, essentially the stack, as having 3 layers. The top layer that we see here, these AI services, they can be integrated and used pretty much immediately in applications where developers have little experience or time for developing models from scratch. The bottom layer of the stack is for expert machine learning practitioners who work with the framework or at the framework level and are comfortable building, training, tuning, and deploying machine learning models. The middle ML services layer provides features and tooling for developers and machine learning experts to use a more managed option. This increases the speed at which they train, tune, and deploy their machine learning models. Let's go ahead and take a closer look at the middle layer of the ML services with Amazon SageMaker. Traditional machine learning development is complex, expensive, time-consuming, and error-prone. Amazon SageMaker removes the difficult work from the process and empowers you to build, train, and deploy ML models quickly. Before SageMaker, doing ML was just too hard for most customers. By making ML easier at low cost, customers can make better use of their data, which is both valuable and differentiating. Amazon SageMaker makes it easy to deploy your trained model in production with a single click, so that you can start generating predictions for real-time or batch data. Let's have a look at a use case here. The National Football League, or NFL, has 180 million fans worldwide. They have engaged with Amazon Machine Learning Solutions Lab. They had a problem where basically they were generating 3+ terabytes of data and had over 1,500 plus hours of playtime per week. They were gathering lots and lots of data, but they needed a solution for real-time stats, for reporters and sports announcers to be able to generate those stats during the game, while it's being played. The solution they picked up was something called Next-Gen Stats. Live data was streamed to AWS from RFID tags on the players themselves and the ball that was being used in the game. Then those machine learning models were built within Amazon SageMaker, so that the predictions could be made in real time. That's a really good real-life application for being able to generate that data and report on those metrics for all the fans, the newscasters and sports announcers to get that information as the game was being played in real time. In this demonstration, we're going to have a look at 2 machine learning services. The first is Amazon Transcribe, and then later is Amazon Comprehend. We're going to start by using a real-time transcription to transcribe what I say into text. Let's click Start Streaming and speak into my mic. Hi there, my name is Jack. I really love pizza, but I hate pineapple on my pizza. I think I'll order some pizza for next Tuesday. And you'll see here that my speech has been transcribed into text. Let's copy that text and use it in our next demonstration. Amazon Comprehend is another natural language processing service where you can analyze an input and process it in different ways. Let's paste in our copied text from Amazon Transcribe. When we analyze this text, you'll see here that we can get an output of its contained entities. You can see there's a detected person, Jack, and there's a detected date of next Tuesday. We can find some key phrases, determine the language or languages of the text, which is English. We can look for personally identifiable information, or PII. I can see that my name Jack is detected. You can also find the overall sentiment of the text. You'll see here that it's mostly a mixed sentiment because we love pizza but we hate pineapple. And then we can dive a bit deeper into targeted sentiment, where you can determine the specific sentiment of entities within the text. you can see the positive sentiment of loving pizza and also the negative sentiment of hating pineapple. And then finally, there's also syntax. Now, as with all AWS services, we have an Internet Accessible API, which we can use to build our own custom applications powered by Transcribe and Comprehend. In this final part of the demonstration, we have a full application combining both services where I can input some recorded audio and then obtain the targeted sentiment analysis with my own custom interface. I'll start by uploading a recorded book review. Once uploaded, it will be sent to the Transcribe service, where you can see here the resulting transcription as text. Then this text gets sent to Amazon Comprehend to show the targeted sentiment analysis results, determining that I had a positive sentiment towards the book's storyline, but I had a negative sentiment towards its long length. And that concludes both our Amazon Transcribe and Amazon Comprehend demo. Next up, let's look at blockchain. Blockchain technology is well suited for complex workflows that span multiple organizations. Some of you might be familiar with different implementations of blockchain. Possibly one of the most significant or recent implementations of blockchain is Bitcoin or Ethereum. But blockchain can actually be used in a variety of other applications too. And if you're not familiar with blockchain as a concept, blockchain makes it possible to build applications where multiple parties may need to exchange transactions and maybe there isn't a central authority in that situation. Here we're dealing with the notion of decentralized trust. But today, in order to use blockchain in a variety of different applications, it's actually pretty difficult to get started. Building a scalable blockchain network with existing technologies is complex and hard to manage. There are a couple of things that each of the network members in the blockchain or those who participate in the blockchain need to do. One is manually provisioning hardware. Another is installing the software, knowing what is the right version of the software that needs to be implemented and also keeping those things up to date. Creating and managing certificates for access, control to the blockchain, and then configuring network components. None of these things are insignificant. Especially for something as complex as a blockchain, it cannot be easily implemented. Let's take a further look at what is blockchain.
A blockchain is a distributed ledger that is decentralized, distributed, and immutable, enabling automated process workflows. Let's look at an example that demonstrates how this technology works by visiting the voting process. Traditionally, people go to a trusted location to cast their vote. They mark their ballots, which are submitted through a centralized, trusted party. It's a system that's been developed over a long period of time. But what if, instead of mailing a ballot or visiting a voting booth, you vote using a private digital voting token that's linked to your identification when you register to vote? With a distributed ledger, voter registration, verification, collection, and tallying can be automated. And it's trusted by everyone because identities are protected with digital signatures. The ledger is shared across multiple parties, and any changes made must be agreed upon by all. Participants can see the history of the immutable ledger, replacing the traditional previous need for a trusted third party. This is just one example of how blockchain technology can transform a common process. So how can building a blockchain on AWS be beneficial? You can build a superior blockchain solution by using AWS APIs and service integrations. Just like with a database, you can use the wide range of AWS capabilities to perform various functions on a blockchain. For example, technically savvy voters could incorporate AWS analytics services to gain insights to what is taking place on a blockchain. They could also create live streaming visualizations of how each group is voting across a geographic area. Give your blockchain superpowers with AWS.
Let's look at some example use cases for blockchain here. Shipping. Blockchain can be used to ensure the entire history and the integrity of that history of a shipped item as it's moving from one country to another and going through that entire shipping system all the way through to delivery. We can ensure the integrity of that item. From raw sourcing all the way through to delivery, we can independently audit and verify that the entire journey there to make sure that the item that was shipped, where it originated from, the item that we are receiving, with a certain degree of confidence. With blockchain, supply chain companies can document production updates to a single shared ledger, which provides complete data visibility and a single source of truth. Another really big use case here is finance and banking, assuring that the transactions are legitimate. Having a way to basically be able to agree amongst multiple different parties within a network that those transactions are valid and correct. Let's now see some of the qualities of blockchain that enable those use cases. First, this idea of decentralized trust. We talked about financial institutions, maybe mortgage lenders, basically being able to agree amongst multiple different lenders or parties that a certain transaction that happened truly happened. They're able to agree on a sequence of steps, or the origination of a loan and various components like that. All of the participants in the blockchain network here are able to agree on what happened. And importantly, they have transparency to be able to do that. Shifting over to the benefits here. In terms of the transparency around those transactions that happened, every member of that network is able to participate and have the visibility to what transactions have happened and the data behind those. Immutability. In terms of the transaction, it can't be altered in any way. Once it has happened, it is permanent in nature. And auditability is one of the other benefits that we get here. Being able to audit that certain controls were followed and certain regulations were followed. It's permissionless. The idea that we don't necessarily need to have a certain central authority to be able to give permission within the network here. Everyone is in agreement or not in agreement based on a consensus model. Now, in order to get this decentralized trust and the associated benefits, we need to be able to set up the blockchain. It's actually quite complex to set up a blockchain in terms of standing up the right infrastructure, using the right applications, and the right code to be able to do that. One solution to this is AWS Blockchain Services. Amazon Managed Blockchain is a fully managed service that makes it easy to create and manage a scalable blockchain network using popular open source frameworks like Hyperledger Fabric and Ethereum. This is something that makes it a lot easier for multiple parties or peers on a network to set up a blockchain. Amazon Managed Blockchain is fully managed. The idea behind fully managed in this case is that you don't necessarily need to wait weeks and weeks for the blockchain to be built out according to the specification. You can create a blockchain network in a matter of minutes. It has open source variety, as you have the support for two popular frameworks, Hyperledger Fabric and Ethereum. It's decentralized to democratically govern the network. Don't have any one member that is more important than another member, or that can override or change or mutate the state of certain transactions. There are lots of other components of this, but also a familiar pay-as-you-go pricing structure, only paying for the resources that are being used. And it's integrated, of course, with other AWS services that you can really take development on that blockchain much further. Let's look at one example of this being used. Nestlé is a global food and beverage company with more than 2,000 brands and distribution across 189 countries worldwide. They wanted to uncover transparency around its coffee bean supply beyond just the brokers and suppliers. They really wanted to have an understanding of traits of the raw materials and more visibility into that. They wanted to track every point in supply chain for this premium coffee. They chose Amazon Managed Blockchain to trace back every single step in the supply chain from the farmer to the grader to the roaster and then to the packer. You think about all the steps that are going along in a typical process of actually growing and sourcing all the way through to when those are being packed and eventually sold. This is an excellent use case where you want to understand the supply chain. In the case where the largest amount of coffee bean procured around the world, Nestle and their customers can now track the high-quality, single-origin coffee from a farmer, logistics, distribution center to the customer. Next up, we have AWS Ground Station. Satellites are used for a wide variety of use cases, including weather forecasting, surface imaging, communications, and video broadcasts. Sending satellites into space is becoming more and more common and accessible. We're getting more data back from the satellites than ever before. Some real-world examples include weather forecasting and agriculture. Being able to monitor crop health and the use of water across fields allows commercial fruit producers to use resources more efficiently. Another example is global shipping and anti-piracy. Understanding accurate ship positioning around the world using satellite imagery and telemetry. Earth observation and fire safety, helping fire commanders understand where the lowest heat entry point to fight fires is and the most efficient way to do so. Retail forecasting. As simple as it may sound, understanding how many cars are parked in a small mall can help vendors understand how often people are going shopping and how much money they are spending within those retail stores. Getting this data back has become much more accessible, but there are still some challenges that remain. Even as it's becoming more common and more accessible to send satellites out to space, the infrastructure required to be able to bring data back is still challenging for governments, universities, and businesses. Today, you must either build your own ground stations and antennas, or obtain long-term leases with ground station providers, often in multiple countries, to provide enough opportunities to contact the satellites as they orbit the globe. The actual ground station antennas in this case are often difficult to maintain, and it requires a high capital expenditure to actually scale up and collect the data. Even if you can get more satellites out to space and retrieve more data, there are still these challenges in terms of the actual infrastructure. This is where AWS Ground Station comes in. AWS Ground Station eliminates these problems by delivering a ground station as a service. This enables you to easily control satellite communication. It is fully managed service that lets you control satellite communications, process that data that's coming in. Scaling your operations without having to worry about building or managing your ground station infrastructure. Those actual antennas that you need to lease or to buy to retrieve that data makes it a lot easier with the ground station service. It's a fully managed service, so you don't have to worry about the infrastructure and scaling components underneath that. It requires no maintenance, software updates, or application downtime. AWS does all the heavy lifting for smooth and secure operations. Pay-as-you-go pricing, pretty incredible. Having the ability to just pay for the resources as you need them. And if you no longer need them in the future, you can release them and you don't have to pay for them any longer. There's no licensing requirements here. You can scale your satellite communications as your business needs. As a further reading, there's a great public sector blog post available called Earth Observation Using AWS Ground Station, a how-to guide. I recommend checking this out if you're interested in finding out how to get started with Ground Station. Upon completion of the guide, you'll end up with a processed image of the Earth captured using AWS Ground Station. Here's an example taken of the United Arab Emirates and Oman. If you look really closely at the center left, you might see the Palm Jumeirah Island off the coast of Dubai. Now we'll talk about AWS Wavelength. Let's first discuss a couple of drivers for AWS Wavelength. With the advancement of onboard capabilities for many mobile devices, sensors like I mentioned before with IoT, video cameras, and many other devices that are generating large volumes of data. This data often needs processing very close to the point of data generation. There's a need to essentially have more infrastructure behind the scenes ready to be able to process that data locally and quickly. There's another driver here in terms of 5G and mobile edge computing. 5G proliferation for the next 4 years, it's projected that billions of mobile subscribers are going to be on 5G or 5G ready equipment. We have new use cases like cloud gaming, video streaming, IoT, connected vehicles, and other applications. And then finally, mobile edge computing. Certain applications, like games demand, require low latency and local processing on those mobile edge computing devices. These drivers are some of the reasons for a need for a product like AWS Wavelength. AWS Wavelength combines the high bandwidth and ultra latency of 5G networks with the AWS services that we talked about earlier to let developers innovate and build a new class of applications using those low latency and high bandwidth with 5G. Essentially, we have scalable capacity within the communication service providers, or CSP, with those data centers that are managed and supported by AWS. AWS compute and storage infrastructure is embedded inside the communication service provider mobile network. All the processing and storage can happen much closer to the end user, again taking advantage of that low latency for the specific applications. You then have access to services in AWS regions. You can develop applications and deploy them for use with 5G networks globally. A few example use cases for AWS Wavelength. Healthcare is one industry where Wavelength is really making an impact. AI or machine learning solutions for processing the images that are taken from multiple different types of equipment in hospitals for radiology and being able to do real-time diagnosis on a very large images or video that's taken from those machines. Connected vehicles, which we'll see an example of in a moment. Smart factories. Industrial automation applications use ML inference at the edge to detect quality issues on fast-moving assembly lines and trigger actions to remediate the problem. AWS Wavelength enables these applications to be realized without having to use expensive GPU-based servers on the factory floor. The amount of technology enabling vehicular communication systems to the degree in which technologies are interconnected continues to advance at a rapid pace. LG Electronics is using a next-generation CV2X platform on the Verizon 5G network using AWS Wavelength to move data in real time. It uses AWS Wavelength for low latency, high throughput for connected vehicles. You might have autonomous or connected vehicles that need to be able to send large volumes of data, potentially stream it in real time, and process that data very, very quickly with low latency and get either decisions or data points back to those vehicles. Over the 5G network, without having to go all the way back to the regions, are excellent use cases for something like AWS Wavelength. Now this concludes the module Innovation with AWS. We hope you found the session helpful with some of the newer innovation areas like IoT, machine learning, blockchain, wavelength, and ground station. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services that you would like to know more about. So please do take the time to fill out our survey and let us know what you think. And with that, I'd just like to say thank you so much for joining us at Awesome Day Online Conference. Join us for Module 5, where we'll talk about the next steps in your cloud journey. Hi, my name is Jack Romanos and I'm a technical trainer here at Amazon Web Services. Congratulations, you did it. We've completed all the modules for the day, so let's go ahead and talk about some of the next steps and ways that you can learn even more. As for these next steps, I would like to invite you to choose your own path. You can start building immediately by going to aws.amazon.com to log into your AWS account or create a new one. We'll talk about some of the ways that you can start building on AWS shortly after this. You can also continue learning. I'll talk about some of the different tools and resources available for you to take this a step further after our session today. And finally, if you want to demonstrate your knowledge, you can sit an exam and potentially achieve a certification in a number of different domains and areas. We'll talk about that as well. In this demonstration, we're going to talk about how to get started by creating an AWS account. Let's begin by opening the following URL in our web browser, aws.amazon.com. Here you'll find the Amazon Web Services homepage. It has a great set of resources to get started, like exploring solutions, exploring the product range, links for training and certification, stories of customer innovation, and a map of the AWS Global Infrastructure Network where you'll be building your applications. On the top right-hand corner, you'll see the Create an AWS Account button. This will take you to the sign up page. From here, you can enter your email address and give your account a name. Once you verify your email address and enter your billing information, you'll be able to create your first account. After this, you'll be signed in and taken to the AWS Management Console homepage. On the top right-hand corner, you can select the region in which you want to build infrastructure in, such as Sydney, Australia. And on the top left-hand side, you'll see a list of service categories you can get started with. Let's say you want to use a compute service, so you can select Compute, and then choose a service, such as the Elastic Compute Cloud, where you can launch your first virtual machine in the cloud and get started on AWS. Here are some tips I'd like to share with you for getting started. If you haven't worked with an AWS account in the past, I have good news. We have something called AWS Free Tier. And the idea behind Free Tier is it helps you gain hands-on experience working with some of the services and features we talked about today for free. In order to create a brand new account and utilize AWS Free Tier, you can go to aws.amazon.com/free. This will provide information on all the free services with either a 12-month trial period or in some cases actually forever free. So take a look at the site to determine the services that you can get some hands-on experience and it won't cost you anything. What I recommend for those who are creating a brand new AWS account is to look at what are called billing alarms. These are really helpful for someone who's just getting started out with some of these services we talked about. You can go to the billing console in your new AWS account and schedule or set up an alarm that will help you know when you're spending over a certain amount. So beyond the free tier, if you decide that you want to use certain services that do incur some charges, you can monitor your costs over time and get alerts. You could also use tools. We have a huge range of developer tools. You can utilize our command line interface, software development kits, and a number of other great resources for developers there. If you go to aws.amazon.com/developer, you can see more about the tooling to get started. And lastly, if you want real-world examples of architectures from other customers and best practices, you can utilize our quick starts. Go to aws.amazon.com/quick start to see some real-world examples. In this demonstration, we're going to talk about how to get started with AWS Free Tier. Firstly, we want to open the following URL in our web browser, aws.amazon.com/free. This will take us to the free tier landing page, which outlines all the free offerings available to you now on AWS. First, we have offers you can enjoy for 12 months following your initial sign-up date to AWS. For example, 750 hours per month of certain EC2 instances for the first 12 months. Then we have always free offers, which do not expire and are available to all AWS customers. For example, 25 gigabytes of DynamoDB storage per month always. And finally, short-term free trial offers which start from the date you activate a particular service. For example, in the first 2 months of usage of Amazon SageMaker. If you want to continue your learning after this awesome day, you can learn at your own pace by going to skillbuilder.aws to gain more confidence and hands-on experience with AWS. We have lots of different self-paced courses, such as the AWS Cloud Practitioner Essentials course. So this way, you can really take your learnings further after this short session that we had. You can also learn from AWS experts. Attend our instructor-led classes by qualified AWS instructors like myself and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. We have a number of different courses and digital content. A great starting point would be the AWS Technical Essentials course. If you still want to get a little bit more hands-on with other resources, we've created ramp-up guides. These give you a variety of different resources across a number of different domains, which can help you gain more real-life experience working with these different services and then also get prepared to become certified in different areas. In this demonstration, we're going to talk about how to get started with AWS Skill Builder. Firstly, we want to open the following URL in our web browser, skillbuilder.aws. This will take us to the Skill Builder landing page, where you can search for digital content to build your cloud skills. I'm going to use the filter on the left-hand side to find myself a machine learning course. I'll select digital training and the English language, and then machine learning for the domain. Let's close our filter and we'll find our results. One of the options that appears is getting started with Amazon Comprehend. We can click on this and see some details about the course, such as the duration, skill level, and outline. If I'm happy to get started, I can click Enroll. Now I'll need a free Skill Builder account to get started. I can conveniently log in using my existing Amazon account. Once I'm signed in, I can then enroll into the course. The course has now been added to my library, and I can get started right away. Once the course loads, I'll be able to read through the course overview, objectives, and what I'll achieve by the end of the course. If you are new to Skill Builder, it's great to use the Navigating This Course section for students to find out how to use Skill Builder and how to interact with the course content. I can then spend the next approximate 90 minutes upskilling myself on Amazon Comprehend. And that concludes this Skill Builder demo. And last but not least, after looking at all these resources and potentially sitting in another training after today, if you feel like you're ready to validate your expertise, we have the AWS certifications. These are from foundational to associate to professional level, with even our specialty certifications as well. Certifications are a great way to earn recognition and visibility by demonstrating your expertise. Whether you're currently looking for a new job, or if you're looking to demonstrate that experience within the company that you're currently working for, it's a great way to represent your knowledge and take that with you. If you want to look into getting certified, we do have the self-paced labs, and we also have a number of other certification resources that you can find on our website as well. Before you go, we have one final demonstration. Over the next couple of minutes, we'll return to Skill Builder and showcase playing Cloud Quest. So here we are, back at Skill Builder. What we're going to do is filter for game-based learning. And one of the options that comes up is Cloud Quest for Cloud Practitioner. Let's select it. We can now browse through the various details about Cloud Quest. We'll now enroll in the course and get started. Once we click Start, the game will begin loading in your browser window. One of the great things about Cloud Quest is that you won't need to install any additional software, as it can run directly in your browser, as long as your system is compatible. It'll take a few seconds to load depending on your internet speed and hardware. Once the game loads, you can get started with enjoying the gamified learning of AWS Cloud Quest. Here we are at the main title screen. This is where we can view notices and start the game.
Welcome to the city. We are happy you decided to join our team. As a new member of our IT staff, you will solve city problems by the Cloud Practitioner job role has been selected for you. Report to the city to begin. A day will help you get started.
On this screen, we can see the available roles and the tasks assigned to them, which we can complete. We're going to select Cloud Practitioner. At this screen, we can customize our character and set our character alias. Now, make sure you make it unique and not taken by someone else, as we can see here. We've now spawned into the city. We are now at the Solution Center, where we will be guided through our building of a solution for our assignment. There are 4 stages to this process. It involves learning, planning, practice, and DIY. In the Learn stage, we will navigate through an interactive diagram of our architecture which we will build. After the walkthrough, a concepts video can be played to learn more about S3 and how we can use it for our solution.
Amazon S3 Overview. Amazon Simple Storage Service. Amazon S3 is an object storage service.
But we're not going to spoil all the fun for you, so we'll exit the video and let you find out for yourself after the session. That brings us to the conclusion of the session. So our key takeaways are to start building, continue in your learning, and get certified with AWS. Thank you for attending, and we really appreciate your feedback so we can better understand the topics and services that you would like to know more about. So please do take the time to fill out the survey and let us know what you think. And with that, I want to say thank you for joining us at this Awesome Day online conference. We look forward to seeing you at our upcoming AWS events. Thank you, and enjoy the rest of your day.